any company, a startup, a SaaS startup is fairly low on resources and it has a lot of data. You have so many tools you cannot manage. You have data flowing in from, like, you have some data in HubSpot, some data in Zendesk, you have somebody filing a ticket, somebody managing actually an interaction within the CRM, and then there is somebody who has product analytics within a database. And all of this exists inside in each and every source explicitly. Generally, engineering is fairly low on bandwidth. You cannot actually prioritize these low priority tasks like building a data pipeline, managing it, and even if you somehow get somebody to build it for you, it's not going to last really long, right? It breaks, somebody changes some schema upstream, and then there is another maintenance nightmare at your hand. Then even after all of this, you build that pipeline, you got it running, it's running, and you know it's running perfectly fine. You get to the insight, but it's not as performant as you expected. So you're running about a D minus on a D minus 1 day analytics on something that you needed to know now. And even after doing all of this, you've already spent enough cost, enough money to actually paying service providers, this licensing costs, and building those pipelines. And at the end of it, you're paying for infrastructure and you're still not getting your actual business goal that you started with. So that's the general scenario for any startup, like where, or any SaaS company, not even a startup, where they have too many sources, not enough resources, and a lot of data, but everybody wants to take a data-driven decision because that's the best way to actually grow. That's where the challenge begins, and that's where uh, there are three primary bottlenecks that we want to discuss. Right. One is there is data that is existing in silos. It is there across each and every uh, within departments, across departments. It's present, but it is not actually being looked at. Then even getting all of this data together, there is like it's not really standardized. It has its own problems. Cleaning itself could be a bigger challenge, and then transforming it to actually get an insight becomes a problem. And within this, you have limited resources, and then you want to scale it because the data is not going to stay really small for a very long time. It's going to grow, and it's going to grow really fast the moment you start tracking it. That's where the scale problem comes in, where you don't have enough resources to actually manage the kind of data problem that you've created at your hand. So that's where the Hevo comes in, right? You have a modern data stack where you're actually uh, having all these sources which are varied in nature with different behaviors. You have something coming in from Salesforce, which is an API-based source. You have something coming in from GA4, which is again API as your blob, which could be a flat file based. You could have something coming in from a database for a product analytics, product utilization. You could have something in a NoSQL database, and all of them act a bit differently with different behaviors, their own nuances, which you may or may not be aware of. And essentially, you don't want to be experts of all these actual applications that you use, right? You just want to use them for the comfort or the use case that they solve, not understand how their data works or how their data model actually works. So you bring in all of this data to your warehouse, and then you try to kind of visualize it, ask, talk to it in some way or form today. But that's essentially what it looks like. You get to bring all of your data together into a single place, and that's where Hevo fits in. It acts like that funnel that is able to actually capture each and everything and move to your data warehouse. So coming to best practices, right? Now, when you go into designing your data platform, how you really want to go ahead with it, right? So you first ask the question, do you want real time or not, right? Near real time, everybody wants some kind of real time data, right? And that's where you take the real trade off. What do you really want in real time? What do you really want at some delay? The best thing about a platform like Hevo is that it can actually support near real time processing for you out of the box. If you're trying it from scratch for the first time, it could be a pretty much long pull, and each and every source may or may not support it in the way that you're expecting. And then comes in, how do you actually build an architecture for a data platform? So you want to maintain each and every layer to some extent at a modular level. You want somebody to orchestrate it for you. You want somebody to actually move the data for you. You want somebody to store it. You want someone to query it, and you want someone to actually being able to actually transform it in a way that you want to, as well as somebody to add some governance layer or security layer on top of it. So, given all these components within your modern data stack, you want to adopt kind of a model architecture where you can plug and play things a lot more easily. You're not kind of logged in. Each and every component is kind of replaceable by itself, right? So you don't want to actually burn a hole in your wallet while you're designing or trying to get an insight just from your own data. Then comes the aspect of how do you want to actually optimize for your storage and query. It's a fairly long topic. It is pretty use case specific depending on how you actually use your data. The scope changes here. So let's take two scenarios. One, if you are today relying a lot on your historical data to actually derive any insight, or the other could be you're fairly going to use your data every week or so, and your older data does not really matter, right? So in both of these scenarios, the approach that you take to actually store your data and how you query it changes significantly. Let's take a scenario with Snowflake where you really want to maybe add some kind of clustering if you are going to query data which is fairly large and fairly frequently. Snowflake does optimize for querying by itself significantly by auto partitioning data, and whatever is queried more often is generally like takes lesser compute to get there. But if you're going to, let's say, go through a few TB of data every day when you're going through your analytics, it makes a lot more sense for you to actually use something like clustering in place. Whereas when you are using something like BigQuery, you may or may not want to use partitioning on reads or on writes, depending on the use case. So the way you actually structure it matters is a function of how you're going to query it or how you're going to model your end product. So before you even go into a deeper design of your data warehouse, it's a very good question to ask yourself. What is the most common query that I'm going to have? What's the most common kind of questions that my end? Then comes the automation of data and governance and security, right? So everybody is kind of under scrutiny with whenever they are dealing with data. Who has access to it? What kind of access do you have to it? When did they last access it? And there are a number of things that are required for audit, for compliance, and anybody who's purchasing anything that is actually interacting with data comes in with a lot of checks that are you compliant with the relevant certifications or not. So that's where the relevant tooling is very important. So if you're looking at an ETL tool or any other uh, vendor, you need to check if they're HIPAA or GDPR compliant as we are. Or there could be a scenario where you want to actually put some kind of access controls on top of who is able to do what. So you're looking for tools which can actually handle role-based access and give you that governance layer so that you can control who can act in whatever way on whichever platform. Next comes optimizing costs, right? So uh, the whole thing is, as I said, does not really need to burn a hole in your pocket. What you're trying to do is essentially uh, build something which is scalable, which is controllable within costs. You can actually predict your overall monthly bill of each and every tool that you're using, right? So it is part of the tool, it is part of your compute, it is also how you're going to how your data grows. Your actual cost growth is not going to be linear, but rather kind of log kind of curve where things are growing, the cost is growing a lot less substantially while your data grows linearly or exponentially, right? So that's how you would imagine each and every tooling out there while you're doing it. For this, one of the best things is to actually decide how much of data you want. Generally, the tendency, given the storage being cheap, you can take a call to move a lot of data in S3 in the short term, and also figure out in the long run how do you really want to optimize for everything in else and right. So you can use initially a object store where you want to park your data, kind of have a medallion architecture, which can significantly reduce your initial costs while you're building a data platform, and slowly figure out what actually moves to the warehouse or not. In the meantime, you can build temporary analytics on top of it if that is another layer that you're looking for. But if you're looking for something that requires long time archival or just storage, and it's not going to really be queried very often, S3 acts as a great intermittent layer or any other object store. So while you're using Evo, you do get this kind of flexibility as well, right? Where you can actually initially park some of your data in S3. We use it internally as well, where we stage and within our architecture. But essentially, what we are trying to say is that while you're trying to optimize your costs, you do need to try to optimize how you configure your ETL pipelines, because a lot of it actually goes in moving the data, and the next part goes in actually transforming it. And the last is like leveraging these advanced analytics capabilities, right? So there is a lot that has moved on since last few years, where you're able to actually configure models which are able to predict give you predictive analytics out of the box. There are pre-built models on a lot of these baseline baseline schemas that are present from all these various SaaS sources, which you can leverage to actually get an insight really fast. So the time from the data delivery to insight has reduced significantly, where you actually don't need to go into a lot of depth of understanding what the source did, but rather you can actually reach to a place where it can start offering you value. So we'll take one such example as we go through the demo. So as we go through each and every bit, right? So when you're optimizing your pipelines for scalability and cost efficiency, what you're trying to do is that you want your pipelines to essentially be built and not being looked upon over a period of time. You're trying to get something that is consistently running and is automated in nature. And it also essentially fits in where it is able to handle any kind of transformations or uh, changes in between, right? Uh, we do support something like CDC based uh, change data capture capabilities for near real time data movement, where we allow you to actually move your data from a database to actually your warehouse in fairly low latency. Then comes on how we manage it, right? So we use fairly efficient ways to actually load this data within Snowflake or Redshift or BigQuery, while we utilize the most optimal strategy on how to merge this data into the warehouse, where we use the least amount of possible credits for a fairly large volume of data itself. Further, we also assist you in, let's say, how do you configure it, how you stage it, what kind of warehouse do we configure while actually moving the data by default itself. So the overall costs are under control always. With this, we move to the case study with Clean. So Clean is a fairly large subscriber management platform, uh, which helps OTT uh, services in managing their subscriptions, right? So they're used by really large companies like NFL, Optus, NHL, with channel. They are fairly known in their ecosystem, and they generally help these people improve the subscriber life cycle or maximize their ROI on it. So what they're trying to do is finding the people who are actually going to pay the most, or how do you ensure there's a high retention for people who are actually subscribed to these channels. So essentially controlling churn or increasing the possible revenue for or area of growth for. So Kling, when they came in, they had a fairly significant challenge at their hand. One of the challenges that they had was that they had a lot of data that was coming in at a fairly high volume, and they needed to unify it. It was a multi-tenant architecture at their end. Data was coming in from different regions, different pipes, different geographies, and they needed to put it together in a single place. Essentially, they reached a conclusion that Snowflake is that destination, and they needed a solution to do it, as they were not able to handle it at their end. They needed a kind of central layer, and their need for data is of a very well-defined SLA, that they need that data within 15 to 20 minutes for them to take calls. And this essentially blows up even further during when some major event happens, right? So when Super Bowl happens, they kind of go into haywire because NFL is pretty much on there. And they need that data, what is happening in pretty much as near real time as possible. So they were using this to actually feed it into models, getting an insight. Those models were returning in pretty much insights on which users are doing what, and they were without this they were actually kind of blindsided and had a trouble predicting churn for or people who will drop off for their income. So what happened was they started using Hevo. They moved all their pipelines, a bunch of them from in-house to Hevo, and they pretty much achieved fairly significant improvement in their ability to forecast churn. They improved their time to insight significantly, where it was taking about an hour to about a few minutes, and they were able to actually build the dashboards that they were looking for and have a fairly fast processing time where they were able to get all of their data in from their source systems to the web.